Yes, children. See here, 1, 2, 2, 3, the numbering pattern. I have written beside this 1, 2, 2, 3, 3, 4, 3, 4, 5, 4, 5, 6, 4, 5, 6, 7. See, beside every alphabet, I have written the numbering pattern here as how we have read in the trick. Okay, so the arrangement pattern was in such a way like SSP, SPS, DPS, DPS, FDPS, right? FDPS. Till here, alphabets order was complete. So the numbering pattern also we have written in the same way as how we have read in the trick. Okay, 1, 2, 2, 3, 3, 4, 3, 4, 5, 4, 5, 6, 4, 5, 6, 7. Okay, till here we have completed. Now, what you have to remember here, one basic thing you have to remember, that is S. This is the S orbital. This can generally accommodate 2 electrons. How many electrons, children? 2 electrons it can accommodate. So number of electrons, how many can we add here? 2 electrons we can add in the S orbital. Whereas if we talk about P orbital, we generally can accommodate, see, there are 3 orbitals here. So how many? Each orbital 2 electrons. So in the P, we can accommodate 6 electrons, right? Now coming on to the D we can remember P is 3, so D is 5. So 5 orbitals will be present here. So 5, each orbital 2 electrons. So this will become the highest compared to this. So children, D1, D we will write 2, right? That means each orbital 2 electrons. Altogether you just estimate it. Each orbital 2 electrons. So here how many it will become? It will become totally 10 electrons. Each orbital 2 electrons. Here 5 are there. 5 2s are 10. So D orbital will comprise 10 electrons. What about F, children? F will accommodate 14 electrons. 1, 2, 3, 4, 5, 6, 7. Okay, totally 7 will be this box is 7 you should have here. So first one 2 electrons, one is clockwise direction, the other one is anti-clockwise direction. So here how many electrons will come, children? Totally 14 electrons will come. 3, 4, 5, 6, 7. 7 twos are 14. So totally 14 electrons can fill here in the F orbital. So what you have to do now, as you can remember this, S2 can be there. Okay, in the S orbital 2 electrons can be filled. In P orbital 6 electrons can fill up. In D orbital 10 electrons can fill up. In the same way, F orbital 14 electrons can fill up. So in this way, you have to remember this order. S is 2, P is 6, D is 10, F is 14. So now what you have to do here, wherever S is there, you just write it down there 2. Okay, above that means here you will write 2. Wherever S is there, you will write 2. Wherever P is there, we have seen here P will comprise totally 6, right? So you will write 6. So wherever P is there, power 6 you will write. That means 6 electrons can be accommodated here. And S is there here, so 2 electrons. P is 6 electrons, then again S is 2 electrons. D, children, generally you have seen here 10 electrons can be possible here. So you will write here 10. So P again 6 you will write. S is 2. D how many children? We have seen here D 10 electrons can be accommodated. So you will write here 10. P again 6. S is 2. Now you tell me F. F we have seen here 14 electrons can be accommodated. So you will write here 14. Here D again 10. P is 6. What about S again? S is 2, right? 2 you write down here. So till here, all the numbering along with alphabets, everything is complete. Now your electronic configuration is ready. Now, if in case you want to find electronic configuration of oxygen, see, oxygen is eighth element. You all know that. What is the atomic number of oxygen? Oxygen is eighth element, right? It is eighth element. That is atomic number you should know, children, in order to write the electronic configuration. Just you should know only one thing, that is atomic number. For example, I took oxygen here. Oxygen atomic number is 8. So how you are going to do to find out the electronic configuration of oxygen? Just you have to count the number of electrons, children, here. Just count the number of electrons here. Like for example, if there is S, then 2 electrons. Linely you come. No need to just skip the pattern. Just linely as how the pattern is, you have to follow it. Okay. So S2 electrons will be accommodated. So this you count from here, children. From the start you count here till 8. Till number 8 you have to count it. So here 2 plus 2, already 4 are done. Here 6 is there. So how much if you are going to add so that it will become 8? See, already till here 4 is done. So what you are going to do for oxygen, if you are going to write electronic configuration for this, then how you will write, 1s2, till here 2 electrons are done, 2s2, here 4 electrons are done now, then 2p4. Okay, like this you are going to write. In this 6 electrons can be accommodated. So here I have took 4. Why I have took 4? Because this atomic number is just 8. Okay children, I hope you all understood this. Now we will go on with the one more element there. Okay, let us take aluminium. Okay, aluminium. So now you can write the atomic number of aluminium here. Okay, so now what is the atomic number of aluminium here? 13, right? Yeah, 13 is the atomic number. So now what you're going to do, you have to write the electronic configuration for aluminium. Okay, this is 13. So you have to count from here 10, 12, 13 means 3p1 should come here. Okay, so in this way you can continue writing the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p1. See, like this you can write it down. I hope you all understood this one. So now children, if you can see here, 2s2, 2p6, 3s2, 3p1. So in this, if you count, the atomic number should be 13. See, till here 10, 12, 13. So this is the correct electronic configuration of aluminium. Now, if in case you want to write the short form for this, you can even write in this way, children. You all should know what are the inert gas elements here. What are the inert gas elements? Noble gas elements, we can say it as. So that is helium, neon, argon, krypton, xenon. Okay, so let us first, if we see helium, we generally come across helium, neon, argon. mostly we see there. So if more higher atomic numbers, if we are going to write, then we will write for argon, krypton and all. So here helium you will have 2, neon 10, argon 18. So now this is enough for writing this electronic configuration, children. Short one. So here helium is 2, right? Helium is 2. So 1s2 is enough for this. Helium, that is the atomic number 2. So we will generally write the electronic configuration 1s2. So 1s2 is the helium configuration. So you can write here valence shell electronic configuration helium. Then you will write the remaining valence shell electrons which are there in 2s2, 2p4. See, this is one more valency shell configuration of oxygen. You can write it in this way. So how many shells are there in the, how many electrons are there in the oxygen valency shell electrons? 6 are there. Okay. So in this way we are going to write. Helium we are going to write now. So you can see 1s2, 2s2, 2p6 is the configuration of neon. In such a case, you can write here neon configuration, Ne. Then you will write the remaining whatever it is left. 3s2, 3p1. This is the configuration of aluminium. Right, children? So in this way, you are going to write the electronic configuration of elements. So just what you have to do, children, just look at here, look at here, whatever it is there, you have to just count it, count and write it down. No other special case here, just you have to count and write it down there. That is enough. Okay, I hope you all got it. So with this, we can close this session here. I hope you all understood this. Try it out with your own even with this simple trick and find out the electron configurations of various other elements which you can just try it and check it out whether this trick is helpful to you or not. Okay, children. Bye everyone. Take care.